right, so the next goal that we have here is I can solve equations that contain rational coefficients. Now remember, a rational number is a number that can be written as a over b, or b doesn't equal 0. So in other words, we're looking at coefficients that are fractions. Now, the steps here are interesting because what first step we're going to do is we're going to find a common factor for the denominators. Okay, and then we're going to multiply each term in the equation by the common denominator. We're not making a common denominator, we're just multiplying each term by the number that would be the common denominator. And you'll see when we do some examples what happens when we do that. Well, actually, I tell you what happens. Um, if I've done it correctly, then that will cancel out the denominators, and it means I will no longer have any rational coefficients. They'll be whole numbers, which makes it much easier for us to solve. So let's take a look at the first question. Okay, the first question says solve, and you can see that we have 2/3 x minus 5 equals 4/3. Now, normally what we would do is we would add 5 to both sides, but then notice what happens. Then I got 4/3 adding 5 to it and still have to solve for x. It's kind of a messy kind of situation. So what we're going to do is we're going to go through those steps. If I had to find a common denominator between, let's take a look at our fractions, between 2 and 3. So over on the side, I'm going to do my thinking. So if I had to find a common denominator, so I'm going to call it CD, between a 2 and a 3, what number would that be? Well, I think that would be a 6, right? Because that would make a common denominator between them. But what I'm going to do with that 6 is I'm not going to make a common denominator. I'm just going to multiply everything by 6. So if I go back to the question, what I'm going to do is I'm going to take that whole equation, that whole thing, and multiply it by 6. When I do that, that means 6 has to go into everything. Okay, so if I have 6 times 3 halves, what happens here is I could put 18 over 2, but how many times does 2 go into itself? Once. How many times does it go into 6? Well, it goes actually 2 times. Now, just to make life a little easier, because it's going to be a little bit harder for you to see, so I'm going to take that 6 and multiply it by my 3 halves x. I'm also going to take that 6 and I'm going to multiply it by my -5. I have an equal sign, which won't affect the 6, but I also have to take the 6 and multiply it by 4/3. So I'm taking each term in my equation, multiplying it by 6. And again, I'll show you what happens when I cancel. 2 goes into itself once. It goes into 6 3 times. So what I'm left here with is 3 times 3, which is 9x. Then if I go to the next one is a 6 times a -5. Well, 6 times -5 is -30. And lastly, let's do the same way we did with our first term. 3 goes into itself once, 3 goes into 6 2 times. So really what I have here is 2 times 4, which is 8. Now, if you look at this line in comparison to our first line, they look very, very different. The first one looks a lot more complicated than the second one. However, they both are equivalent to each other. They both will come up with the same answer. This second one is much easier for us to solve, okay, because we no longer have rational coefficients. So I would finish by solving it, okay, and so what we would do first of all is we would add 30 to both sides. Remember, you must show that to me. And when I do that, I end up with 9x. The 30s are gone, and I have a 38. Divide both sides by 9, And my final answer is going to be 38 over 9. I don't believe that they have anything in common. So you can see that this method, although it has some extra steps in it, it's much easier to solve when you don't have a rational coefficient. So let's try some more examples just so we get the hang of this. Okay, the next one. So to the side, I'm going to again do my thinking. And I'm just writing down my thinking for you because obviously you can't get into my head. Thank goodness you can't. Okay, so if I had to find a common denominator between, let's see, what do we have? Between a 5 and a fourth, between fifths and fourths, what would that common denominator be? That would be a 20. So I'm going to take my 20 and multiply every single term in that equation by it. So I'm going to take the 20 and I'm going to multiply it by the 2/5 x. I'm going to have that 20 and I'm going to multiply it by -1/4. And also I'm going to have that 20 and multiply it by the 3x. Now this works really quite slick, as they might say, but it's really important that you multiply each term by that number. So if you notice, I had 3 terms in my original question, and I still have 3 terms here and 3 20s. Okay, so the reason we did that is how many times does 5 go into itself once? How many times does 5 go into 24 times? So now I have 4 times 2, which is 8, x, and on the bottom I have 1, so I have nothing there. Here, how many times does 4 go into itself once? How many times does it go into 25 times? So I really have 5 times 1, which is 5. And then here I just have the 20 times the 3, which is 60. So now what I want to do is I want to get all the variable terms to one side. And I know that most of you like it on the left side, so let's subtract 60 from both sides. So I end up with a negative 52x. I still have my plus 5. And on this side, I have 0. I'm going to now subtract 5 to both sides. And I'm left with a negative 52. Watch, make sure you keep your signs. And negative 52x equals negative 5. Almost done. Now I need to get rid of the negative 52, so I'm going to divide both sides by negative 52. And what I end up with is x equals 2 negatives here make a positive, and 5 does not go into 52, so my final answer is 5/52. So let's do one more question together. And here's this one. Now, this one looks different, and the reason it looks different, let's just go back a second and see. Okay, compare this to this. The difference being is I have variables and numbers on top of fractions. Now, really what's happening here is I'm just going to put a bracket around each numerator because that belongs together over the denominators. But the same steps apply. If I had to find a common denominator between 2, 7, and 14, so between 2, 7, and 14, I think that we would all agree that that would be 14. So I'm going to take the number 14 and multiply it by everything, all the terms. So I have 14, and remember I put a bracket around my numerators, plus 14 times the 3x minus 1 over 7, and my 14 over the 5x minus 2. Oops. Sorry, my writing utensil sometimes just doesn't want to behave. Over 14. And just get rid of that line there. All right, so just like the previous examples, if we did it, if we came up with the correct common denominator, we should get rid of the 2, 7, and 14. 2 goes into itself once, 2 goes into 14 7 times. So what I'm left with is 7 bracket x plus 2, and it would be over 1, so I don't have to put that, plus 7 goes into itself once, 7 goes into 14 2 times. So I'm left with 2 bracket 3x minus 1 equals 14 goes into itself once, 14 goes into 14 once, so I'm left with a 5x minus 2. Now what we're left with are those questions that we did before where multi-step, in the sense that now I have to get rid of the brackets. Now to get rid of the brackets, remember we do the distributive law. So we end up with 7 times x, which is 7x. 7 times 2, 14. Oops. 7x plus 14. The next step is my next one. So I have a 6x, and 2 times negative 1 is a negative 2, equals, and this time I can just take this bracket off because it's just a positive 1 in front of that bracket. Now I have quite a few terms on this side, so that probably means something goes together. So let's take a look. What goes together here? I have 7x and I have a positive 6x, so I have 13x's. I have a 14 minus a 2, so I have plus 12. Next step, I want to get all my variable terms to one side, all my constants to the other. So I'm going to subtract 5x from both sides. When I do that, 13 take away 5, so we're looking at 8x. I still have the positive 12, and it equals, the 5's cancel, I still have a negative 2. Make sure you don't forget that negative sign that's there in front of it. So all the variable terms are to one side, so now I'm going to subtract 12 from both sides. And when we do that, we end up with 8x. The 12's equals 0, and we have a negative 14. Almost finished. Divide both sides by 8. And when we do that, we have a positive 1x equals a negative number. Okay, 8 doesn't go evenly into 14. However, 2 goes into both 14 and 8, so we would end up with a negative 7 quarters. Okay, and I don't want a decimal. I want it as negative 7 quarters. Okay, so a little more complicated, but if you look at that question there, that's one reason why you have to show your steps. It helps you keep track of what you're doing, and if someone else is looking, they can see exactly what you have been doing as well. Okay, so you have worksheets to work on with this, and when I'm around, make sure that you're asking for assistance if you find this extremely difficult and don't even know where to start. Okay, see you tomorrow.